Hi everyone, welcome to today's learning. Till now in our playlist we have covered what is data, what is machine learning, what is artificial intelligence, and the machine learning life cycle. In machine learning life cycle we have covered exploratory data analysis and data preprocessing. From today we are going to talk about machine learning models. Model building is an important step in machine learning life cycle. In this video we are going to cover an important simple machine learning algorithm, that is linear regression. What is simple linear regression and how to calculate, and what are the assumptions of simple linear regression? Simple linear regression is used to model the relationship between two variables and can be very useful for making predictions. The two variables in simple linear regression are the independent variables and the dependent variable. The independent variable is the variable that is used to make predictions, and the dependent variable is the variable that we are trying to predict. The formula for simple linear regression is y is equal to beta naught plus beta 1 x plus epsilon, where y is the dependent variable, x is the independent variable. Beta naught is the y-intercept, beta 1 is slope, and epsilon is the error term. Let's say we want to predict a person's body weight based on his height. Then the person height will become the independent variable and the body weight will become the dependent variable. We can use simple linear regression to find the best line that fits the data. You can see from the plot that we have defined weight is equal to 80 plus 2 times of height, which means beta naught will become 80 and beta 1 will become 2. If the person height is 50 inches, then his approximate weight will become 180 pounds. We can assess the accuracy of our predictions by calculating the coefficient of determination, also known as R squared. R squared represents the proportion of the variation in the dependent variable that is explained by the independent variable. A higher R squared value means that the line is better fit for the data. We will discuss about the R squared in our upcoming videos. In summary, least simple linear regression is a statistical method used to model the relationship between two variables. Before going to apply the simple linear regression algorithm, we have to see for some of the assumptions in the data. The very first one is linear relationship. There should be a linear relationship between independent variable x and the dependent variable y. So the best way to know by using the scatter plot of x and y. If there is a relationship exists, the data points in the plot fall along the straight line. If we are not finding any linear relationship between both dependent and independent, we can avoid this problem by using nonlinear transformations like log transform, square root transform, etc. And sometimes we can add some other independent variable to the data and we can try to avoid this kind of problem. And the next one is independence of observation. Residuals should not have any consecutive patterns, and residuals should be independent. We can identify this by plotting the residuals versus time. If we have a problem of independence of observations, then we can avoid by adding the seasonal dummy variables or by adding the lag. The next one is homoscedasticity. Residuals have constant variance at every level of x. This can identify by plotting the fitted values of the model versus residual plot. If there is no cone shape of data points we have seen in the plot, then it is homoscedasticity. To fix this, we can transform dependent variable using log transformation. And the last one is the distribution of residuals should be normal. We can plot cube plot like a quantile and quantile plot, which to determine residuals follow normal distribution or not. If this assumption violated, then we can check for any outliers are present, or we can do some nonlinear transformation. Then we can avoid this kind of problem. That's all for today. Thank you for watching the video.